Hello, in this video we will show how to test for normality and equal variance for ANOVA using R. So we know in ANOVA, for example in one-way ANOVA, the purpose for doing ANOVA is to test if odd test grouping population mean are the same or not. But for the prerequisite or the assumption for the ANOVA is that we assume odd population from the test group are normally distributed and have equal variance for each group. So if these assumptions are not met or very significantly different from what we have expected, then the results of the ANOVA will be skeptical. And here we will show how to, in R programming, to do several tests for normality and equal variance. So for the normality, we can use QQ plots to test upon the ANOVA test object called fit. And for equality or homogeneity of the variance, a test called Bartlett's test can be used. So next we will show how to do these test functions in R Studio. So same as previous videos, we used data called cholesterol from package mult.conf. So we load this data and show observations of this data frame. So there are two columns, very clear: treatment and response. So response is the dependent variable, and the treatment here 1 time, 2 time, 4 time, different treatment groups, and so on. So first we will create an object from the ANOVA function called AOV with the response as dependent variable and treatment as independent variable. Then we show the summary of this object from ANOVA. So ANOVA test is significant, so which means the treatment group mean are not the same. Then next we will show to test the normality, we will load the library called car first. Then use QQ plot for the fit. Fit comes from ANOVA function we have done, and use the option called simulate true and main use QQ plot label. So this is the QQ plot from this function upon the object of ANOVA. You can see the horizontal axis is T quantiles and the vertical or studentized residues from the fit. Now these two scatter plots, you can see odd points lies in this region, this blue region. So which means the normality assumption is met. And for testing of homogeneity of variance for each group, can use Bartlett's test function upon the response and treatment data from this original data frame, cholesterol. So the results quite easy. The Bartlett's test has a test statistic and degrees of freedom and the p-value 0.9653. So we will focus on this p-value because this number, this probability is much larger than the significance level, say 0.05. So this Bartlett's test is not significant. So which means we do not reject the null hypothesis, or we do not reject the assumption that each group in this ANOVA have same variance. So we hold this assumption. So say this assumption of the equal variance is true. We do not reject it. Thanks for watching.